Good morning. Myself, Dr. K. Srinivasrao, working as a professor in the Department of CSC and AML department at G. Pullareddy Engineering College, Kurnool. So, in this video, we will discuss about the process concepts in operating systems, the basic concepts related to the process. So, first of all, we will see what is meant by the program and a process. So, a program is nothing but set of the instruction, and at a time the main memory can store multiple number of the programs, but only one program will be in the execution at a time. So the program which is in the current execution, we can call that program as a process. So process is nothing but a program which is under the execution. So like a program, a process may contain different multiple information, like it may contain some set of the instruction and we can call it as the text section, and also it can contain the program counter and some registers for storing the data as temporarily, and also it can have the stack. So this stack is useful while storing the return addresses at the time of recursive calling, and also it can have the data section which contain all the variable local and global variable declaration. Apart from that, it can also have the heap which can store the memory dynamically runtime. Okay, so simply here we say a program is the passive, so it is not in the execution, and a process we can call it as a active, so because it is in the current execution. And when a program becomes the process is immediately after the execution. So initially we have the program in the memory. So whenever the program is executable, it becomes the executable, then the program becomes the process. So here during the execution, we have multiple states of the process. So it means at any time during the execution of the process may be present in any one of the five different states. So these are the five states of a process. One is the new, running, waiting, and ready and terminated. So we'll see one by one process. So the first state is a new state. It means immediately after the creation of the process, we can say that the process is in the new state. At the beginning, we can call the process as in the new state. Next, second one is running. So when the after creation of the process, then it is ready to execute. The process is ready to execute, then we can call it the state as a running state. And the third one is waiting. So in the second state, the process is in the execution, means it is doing some operation. So at the time of execution, if the process wants to do some operation, like it wants to read some input data or it wants to access the output data, then it will wait for some time for accessing the input device or output device. So whenever the process is in the waiting for input or output devices or some event to occur, then we can say that the process is in the waiting state. That is the third one. So the third one is the waiting. When a process is waiting for some event or for accessing the input or output device, then we say that the process is in the waiting state. And after that, the ready state, the fourth one is ready state. So after completion of the IO operation, then the process is ready to execute, because whenever the process is in the waiting state, then the CPU will be idle. So instead of present in the idle state, the operating system will allocate the CPU to some other process which is ready to execute. So after completion of the execution of the first process, then it is ready to execute. So the process is said to be in the ready state. And the last fifth one is the terminated state. So the terminated means after completion of the process execution, we can say that the process is in the terminated state. So these are the five states of a process. So new state means at the beginning, running, waiting for the event or for IO device, and ready to execute, and the last one is terminated. And this is the process state diagram. So as already we have discussed, there are 5 states. One is the new, ready, running, waiting, and terminated. So see the first one, new. Immediately after the creation of a process, the state changes from, the state is called new state. And whenever if it is ready to execute, then the state of the process changes from new state to ready state. And at the time of the execution, if the process can start the execution, so we can call it as it is in the running state. Then at the time of the execution, if any an interrupt occurs or some event to be occurred, or the process wants to access any one of the IO device, then the process state changes from running state to waiting state. Running state to waiting state. And after the completion of the IO operation or input event, then again the state changes from waiting to ready. Okay, so the loop is repeated here. Ready, running, waiting, ready, running, waiting, and like that the loop will be repeated. For example, if there is no event or if there is no need to access the input or output device, the process can do the execution, and after some time the process can stop the execution. So exit, the process can be exited. When it will be executed, after successful completion of the execution, the process will be exit. So then we can say that the process is said to be in the terminated state. So this is the process state diagram. And here we have the process control block, so which stores the total information about all the process. So every process is having some information. So the information about all the processes is placed in the table called PCB, stands for process control block. It is also called as a task control block. So what type of the information we can store in the PCB is this data we can store, like the process state, like what is the state of the current process, whether it is the new state, ready state, or waiting state, running or terminated. So that state will be present here under the first one, so process state. And next, process number. So immediately after the creation of the process, some number will be given for the process, unique number. So that number we can write here, process number. And similarly, we can have the program counter also. So PC, program counter, which stores the address of the next instruction to be executed. So in the process, one by one instructions are executed. So to execute the next instruction, its address is required. So the next instruction address is placed under the program counter. And like that, we can have the registers also. Registers information is also stored here under the PCB. So it contains what are the registers used in the process and what are the initial values of the registers, like that. And also we can have the memory limit. So means what is the size of the memory, and what is the starting address of the memory, what is the last address, starting address and the last address of the process. So from to the last address, starting address to last address, memory limit. And also we can have the list of the open files. So these total information is stored on the in the form of the PCB, process control block. Apart from that, see here, CPU scheduling information. Like in the next video, we'll discuss about this CPU scheduling. So whatever the scheduling algorithm we are using and the information related to that scheduling is also present under the PCB. And see the accounting information. So this entry contains how much capacity we have used, and what is the log time and what is the time limit, etc. So this total information is placed in the form of the PCB. So process control block PCB contains the information associated with each process. So for every process, there is one PCB. It contains the information related to that process. These are the information we can have for every process. And next we'll see what are the operations can be done on the process. So mainly there are two operations can be performed. One is the process creation and the second one is process termination. So these two operations can be done. So we'll see one by one operation. The first operation is process creation. If there is initially we have one process and that process can create another process. So the first process we can call it as the parent process and the second process we can call it as the child or children process. Again, a children can create another children also. So like that, a process can create another process and that process can create another process. So this can be repeated. So if you repeat this creation, so finally we can have a tree of processes. So tree of processes where hierarchical manner. And immediately after creation of the process, a number will be given, unique number will be given for each process. We can call that number as a PID, that is stands for process identifier. So this ID is different from one process to another process. Here we have the parent process and parent has created one child. When a parent has created the child process, so these are the resource sharing options we have. The first one is both the parent and children can share all the resources. So it means parent having some resources and children if it is having some resources, both parent and children can share whatever the resources available. All that resources are shared by both parent and children. That is the first option we can have. And the second option is the children can share only the subset of the parent resources. It is nothing but, for example, a parent is having three resources like R1, R2, R3, three resources. Then a children can share either R1 or R2 or R3, or it can share both R1, R2, or it can share R2, R3, or it can share R1 and R2 and R1 and R3. So like that, in the second option, a children can share a subset of the parent resources. And the third option is parent and child share no resources. Means separate resources are there for parent and child. So parent is having its separate resources and child also can share, can access its own resources. So there is no common sharing of resources between the parent and resources. So these three options we have while sharing the resources between parent and children. And see here how the parent and child can execute. So parent can do the execution as well as the children can do the execution. So one option is both parent and children can execute concurrently. It means parent started the execution, at the same time children also started the execution. So both can be executed at the same time. Concurrent execution can be done. Both can be done. And the second option, whenever the parent process is created, a children, then parent process will wait for some time until the child process completed the execution. So parent waits until children has terminated the execution. So these are the two options we have for execution of the parent and children. So see the example for parent creation here. This is the simple example in the Unix. And one more point here, for the creation of the a process, we have different system calls, different commands, and these commands are differed from one operating system to another operating system. Okay, so this is the example for a tree of process in the Unix operating system. The first one, a process is created. So PID equal to 1. After that, this parent process has created 3 children, 3 processes are created, and this name of the process is login ID, and its PID, process identifier, is 8415, and this process has created one more children, and this again it was created 2 processes. Like this process creating 2 children. So like that, a process can create one more process, one children, and the children can create another children. So the loop can be repeated. If we repeat this process, then finally we can have a tree structure of the processes. See, already I discussed, for creation of a process, we have the system calls, some commands are there. They are depending on the operating system which we are using. If you see the example for creation, in the Unix operating system, we have a system call called fork. So this system call is used for creating the new process. And after creation of the new process, we can start the execution with the help of exec system call. So these two main important. So fork can be used for creating, exec for starting the execution. And already we discussed, when a parent process will be wait until the child process has to terminate the execution. So the parent process has to wait for some time. So for waiting, there is a system call called wait. So these are the some important system calls we are using: fork, exec, execute, and wait. So if you see this diagram, so initially we have a parent, and this parent has created one child process with the help of the fork system call. Immediately after the creation of a child, one number will be given. So that number is called as a PID. So that number is assigned to here, PID. So PID contain the number allotted for each process after the creation of a process. If that number is equal to 0, if the number equal to 0, then we can call it as a child process. If the number is greater than 0, then we can call it as a parent process. If the number is 0, it is a child process, and it can start the execution using exec system call. And if there is no interrupt, or if there is no other requirement, just simply it can stop the execution with the help of exit. With the help of the exit system call, the child process execution will be terminated. Okay, so this is the one flow of execution. A parent has created the child, and the child has started the execution with the help of exec. After some time, automatically the execution will be completed, and then it can stop the execution with the help of exit. And the other case is, if the PID value is greater than 0, we can call it as the parent. And parent also, for example, it will wait for some time. So when the parent process will wait for the completion of the execution of the child process. So the parent process will be waiting with the help of the wait system call, and it will be waiting until the child process completed the execution. So immediately after completion of the child process execution, the parent process can restart the execution. So parent process can restart the execution. So this is the simple C program for creating the process. So already we had discussed it. So with the help of the fork system call, a process will be created. That number is assigned to PID. If PID is less than 0, we can call it as a child process. If it is less than 0, some error occurred, and if it is 0, then we can call it as a child process. And if it is greater than 0, if the PID is greater than 0, then it is a parent process, and the parent process will wait for some time until the child process has completed the execution. So this is the program for creating a process. That is the first operation. called process creation. And the next process operation is process termination. So process termination is nothing but execution is completed. The process execution will be completed. So you have to terminate the execution of the process. So whenever the process is terminated, whatever the resources we have allocated at the beginning of the execution, all the allocated resources are taken back by the operating system. So after the termination, the process resources are deallocated, taking back by the operating system. Why it will take back by the operating system? Because its execution is already completed. So the whatever the resources allocated, so those are not required. So once we take back the resources, then that resources may be useful for another process. So that's why the resources will be deallocated or taken back by the operating system. And here there is one system call for terminating the execution, that is called abort. So abort is nothing but to stop or to terminate the execution of a child process. We can use the system called abort. Okay, and there are some reasons for terminating the process. Okay, so one of the reason for terminating the process is the child has exceeded allocated resources. It is nothing but already we had discussed, there is a parent process and the child process. So the child can share the subset of the parent resources, or the child can access its own resources. For example, here for the child process, there are only two resources are allocated. If it wants to access any other extra resources, it is nothing but it is exceeding the allocated resources. So at that time, the operating system will terminate the execution of the child process. So that is the one of the reason for terminating the child process. And the second reason is whatever the task assigned. So parent has created a child process for some reason, and it identifies that the task assigned to the child process is not required, then automatically the parent process can terminate the execution of the child process. That is the second reason. So the task assigned to the child process is not required, no longer required. And the third reason is, since the parent is creating the child process, and when the parent process completed the execution, its execution is completed, parent execution is completed, then the the operating system will not allow the child process to continue the execution, because the parent process has completed the execution and it was terminated. The parent execution is terminated. So the operating system will not allow the child process to continue for the execution. So because of these three reasons, a process may be terminated with the help of abort system call. After terminating, whatever the resources allocated, those resources are deallocated by the operating system. So these are the two operations of process. So thank you very much. In the next video, we'll discuss about the process scheduling concept.